talk to people, go out and explore things and learn about things and learn how to model things. That's kind of one of the most important things. You have some complicated problem, learning how to model it in a proper way, and that's kind of the key thing. Obviously, I assume that you have also the mathematical tool. One important thing is, you also have the mathematical tool available to analyze the model, but the really important thing is to be able to come up with a model, to somehow give structure, to somehow formalize, if you encounter some engineering problems, to somehow formalize it, to put it on a solid foundation. Yeah. Of course, as I said, you also need the mathematical tools, but the crucial thing is really to come up with the model. But also don't overemphasize the model. So, I mean, there are people that then calculate capacities to the 10th digit and stuff like that. I don't think that is, I don't think that is terribly important. The first 3 digits are important, but anything beyond that, anything beyond, I've seen many people, 2nd order, 3rd order, 1st order stuff, Yeah, so, well, not, sometimes it's justified, sometimes not. So be careful. Don't read too much into a model. Models are very important, as I said, because it's the starting point for a theory, but don't overemphasize them because it's always an approximation to reality. There's always something that you don't capture.
While we're talking about words of wisdom, just something my advisor said to me when we were trying to pick a topic to choose, pick a topic of research to fixate on, to focus on in the next few months here. Try to pick something that's solvable. Hopefully, you need to graduate, right? That's unsolved, better be you, otherwise you shouldn't graduate. And that's interesting, right? Now this is really the hardest requirement. It's interesting to whom? Well, it had better at least be interesting to you, but hopefully also at least to a few people around you, interesting enough that it will have some staying power. And then this is the hardest to judge. It's how do you say something is interesting? But it's hard to judge. It's more of an aesthetic judgment, really, almost than necessarily a quantifiable thing. And actually, if you think about it, any 2 out of these 3 is somewhat easy to do, right? It's easy to do something that's solvable and unsolved. Just pick any problem, change a number from 2 to 3, and maybe it's easy to find such a problem, but maybe it's not necessarily interesting, and you can try the other combinations yourself. But finding a good research topic, finding a good research problem, finding something for a thesis, or the reason it takes so long is because it's a heavily constrained problem. I don't really have that much to say. I realize I was sort of rambling in my description of this panel. It was sort of deliberate, just so that people have the cover to say anything they want to, any sort of wisdom they'd like to share, right?
Can I ask a question to the panel members actually?
Okay, sure.
So sometimes when I ask a student, hey, what kind of program do you like? Why you are working with Jackie? I mean, at first he's cool, but why exactly? Well, they say, his problem is kind of interesting, is very well defined, and mathematical problem. So we're comfortable. We don't need to explain to people why this problem is important, and we know a couple of math and tools, and then we can start. Versus working with other people like machine learning, data mining, I always need to find a new problem, justify that this problem is important, and to the people around, and then they may not agree, and then I feel very frustrated. So. I would rather prefer to work on some problem that people all recognize that they're very important already. Yeah. So it's well defined. So what do you feel, I mean, to you, information theory, this area is really full of a bunch of interesting, well-defined type problems, or this is only a small part of it, actually other part of the information theory problems, or more interesting, or you guys are even you prefer people to explore new problems rather than working on old problems?
Well, you should all start asking questions soon, otherwise we will start. I think that when you write papers, it's possible to measure yourself by how few people can actually understand your paper. I think that's also not very healthy. I think that there are some great examples of information theorists who sort of gravitate towards beautiful problems. I mean, an example is Coburn, an example is Jacobson. And I think that the rest of us need some external motivation. But I think that it's not a weakness to look for problems that are appealing.
I agree. So we have this experiment running in my house, but one so far surefire way of putting my girlfriend to sleep at night. I tell her about what I've been thinking about these last few weeks, months, years. It works without fail. So she's a lawyer by training. So my hope is that sometime in the next few months, years, I'll finally hit on a way of, well, firstly, my own aesthetic choices of problems to work on will be interesting enough, and secondly, my way of describing them will maybe be good enough that she'll stay awake longer than expecting. We did stay awake one whole, like until 5 a.m. one day, just when I was just describing high school chemistry to her, and chemistry was not my strongest topic. But clearly, there are some endeavors of intellectual endeavors that would keep it awake. But yeah.
Maybe chemistry was a metaphor.
Any questions from the audience? Yeah.
So I actually have a question which is might be important for all of the students here. Basically, we are all still at early stages of our research career, and this question is for everyone in the panel. Actually, everyone is going to answer. So, Professor Kellerman gave a brief comment during his lecture today about the market, about signal processing versus information theory, job market, whether it's, I don't know, academia or in industry. So, since we are still at early stages, perhaps it's a good time to take advice from experienced people, what to do and what not to do. You can comment
Yeah, not really. Yeah, well, I guess it's hard for me to. I'm trying to still formulate like a clear. Thoughts are not particularly clear in my head as to how to answer that question. Let me try. Well, at least like when you're out on the job market, I suppose to begin with, yeah, it's a fact that like unless you're a superstar, unless you have solved some like really big problems when you were in graduate school, like which would immediately snap you up. I mean, which would like cause the big universities to come running after you, trying to snap you up. You have to make yourself marketable. So for the vast majority of us, of you, now that I have jobs, most of us here have jobs, so it's not me looking for jobs anymore. So for most of you, most of you are going to be kind of the majority. Very few of you are going to solve the big problems, like it or not. That's how it works. So for those people who don't have like kind of sort of award-winning paper in like a major conference or journal, and kind of like have 100 million citations, etc. It's ultimately you have to try to figure out where the jobs are. It is a question of making yourself marketable, figuring out what areas it is. See, this is purely in the search for jobs. It's completely different. Once you get a job, what you do then is completely different. By the way, this is something that you should keep in mind. It's all about first getting a job. Once you're in, you actually have a lot of freedom to do what it is you want. Once you're in, it's all a question of sort of getting in the first place. So that's the trick, is somehow to manage to get a position from which then you can like branch out. Yeah, and that sort of getting your sort of your foot in through the door can be difficult. And there, I think you have to sort of be a little savvy, market yourself well, sort of try to whatever it is that you do, whatever drives your interests, try to see how it meshes with the hot areas that people are looking to hire young faculty in. It's just a game that one plays initially, but so as I said, like, it's really mainly to get yourself in through the door, and once you're in, doing what takes your fancy is much easier. So, I mean, yeah, initially there is a little bit of marketing involved, making sure that you get your foot in through the door. I mean, so this is my personal take on it. Others may disagree, but that's what I think needs to be done.
Just before Rob answers, I just wanted to clarify, were you asking purely about academic positions or possibly about other positions?
Okay, so I think you should approach it as information theorists. So there's a channel, and you're trying to get your bit through this channel, right? And like Nathan said, you have to figure out what sort of bits your channel wants to accept. All right. So I think if you're going for academic jobs, it's you have to have a CV that clears the interview threshold, which means that you have to write enough papers. They have to be in good places. Once you get an interview, it's a different situation. Right? So let's say you're an information theorist, you're interviewing somewhere. If the folk in information theory and communications and signal processing don't like you, you're not getting that job. So let's assume that they like you. Now your job is to convince the other people in the department, who might be optics guys or electromagnetism guys, and why are they, so you want to give a talk, and then you want them all to rush down to their department chair and explain why it is that you should be hired. Now, what on earth would convince them to do that? So, in the spirit of Naveen saying about marketing, I think that you want to give a talk that communicates that by hiring you, an information theorist, it's actually going to make them more successful. And so this is all about information theory as a lens for solving the world's problems. I think that if the department feels that you are that kind of person, then they will gravitate to your side. If they feel that you're going to sit in your office and think deep thoughts that don't concern their work, then maybe they're going to be okay with hiring you, but they're not going to agitate for you. So I think that you ought to think actively about how to get your bit through those channels.
Yeah, one word I have for young PhDs who want to eventually get an academic job is that you shouldn't drag on for too long. Okay? If you don't get a permanent job after 5 or 6 years, then chances are that you won't be able to get one in your life. Okay? The reason is that I think that it's a timetable. I mean, a lot of people, a lot of young people just don't notice that there's a timetable or schedule in academia. At different point of time, people expect that you have achieved certain things. You cannot be a PhD who have 10 years of experience and apply for an assistant professor. It doesn't work that way. Okay? And so the reason I said that There's no particular reason for that. I mean, but the fact is that if you don't get a permanent job after 5 or 6 years, 5 or 6 years after your PhD, then people will think that, oh, okay, this guy can live without a permanent job, and they won't give you one. Okay, that's reality.
By permanent job, do you mean
tenure track position.
Pascal is possibly a counterexample to that?
Pascal was an industrialist for a long time. He just wandered into academia.
Well, I was in an industry lab, so for a while. No, the important thing, I mean, what makes
but
you...
you had a permanent job.
Yeah. As life is permanent. The important thing is, I think, be broad in what you know and what you can. I mean, don't just be able to prove upper and lower bounds and stuff like that. I think it's important that you can program and stuff like that, really also, that you're able to use computers in a sophisticated way. So with that, you open much more your spectrum of jobs that you can find out there. You also make your life much more easy, much more interesting. I think. So if you can prove Riemann's conjecture or Riemann's hypothesis, great. But for the rest of us, it's good to be broad, to be mathematically broad, also computer skills, programming, and so on. That helps you a lot. So it opens your job's perspective in many ways. You can find this. You can talk to other people. That makes life much more interesting, I think. So as an advice, when you do a PhD, don't just focus on your little narrow project. Be broader, look out, and have skills in various fields, so that whatever the jobs will be, you have suitable skills.
Or more generally, widen your appreciation of things.
Swan?
So let me ask a question which is kind of before the job